Here we go. First derivative test. So now we're going to combine, we're going to kind of like continue what we talked about yesterday with the increasing and decreasing.
Oh, I totally just botched derivative. Great.
Okay.
We're going to start with
So here is the first derivative test. It's pretty straightforward
Is
here.
it hard?
No.
How many questions?
Let C be a critical number. So here we're using C now as a critical number. Before, C was just like, you know, in mean value theorem, C is not a critical number. It's just, you know, kind of the x value that makes your derivative equal the average rate of change. But in this case, we're letting C be a critical number of a function f. Ooh, that is continuous on an open interval I containing C. Okay, so C is a critical number, and I is just an open interval. So yes, you can refer to an interval by like a capital letter. Okay, so the interval could be like from A to B, or you know whatever kind of letters you want to use there. It's just like a generic open interval that C is in that interval. Okay, if f is differentiable okay, so if f is differentiable on the interval, except possibly at C, right? Because remember, how do we find critical numbers? We take the derivative and set it equal to 0, or where the derivative is undefined, right? So if the derivative is undefined at C, it wouldn't be differentiable at C. So when I'm saying f is differentiable on that interval, except possibly, it could not be differentiable at C. That's okay still. Okay. Then f of C can be classified as follows. Okay. So C is that critical number there of a function. Okay. If f prime of x changes from negative to positive at C, then f of C is a relative and I'm gonna hold off on filling in the blank here because I want you guys to kind of think about this. So f prime, the derivative, is changing from negative to positive. Therefore, the original function is changing from what to what?
It's a relative extreme.
Well, yes, but it's a relative minimum.
Okay, but answer my question though.
Oh.
If f prime of x changes from negative, so if f prime's negative, that means the original function is what? Decreasing. If f prime is positive, that means the original function is what? Increasing. So, if f prime is changing from negative to positive at C, that means the original function is changing from what behavior? Decreasing to what behavior? So what type of relative extrema occurs when our function is changing from decreasing to increasing? Our relative minimum. Relative minimum, right? I'm getting a little wave there, all right? Relative minimum. Okay, of f.
Bet I can guess the next one.
All right. So, and this is because f is changing from decreasing to increasing. it's going to be hugely important that we are able to translate information from the derivative to then the original function. So what I just had you do, right, when I said f prime was negative, that means f was decreasing, and f prime is positive, that means f is increasing. We need to be very comfortable eventually with, with being comfortable transferring information from about the derivative to the original function. Likewise, we can transfer from the original function to the derivative. So if I see like an interval where my function is increasing, that means on that same interval, my derivative of that function will be positive. And same thing is true then for decreasing and then derivative being negative. So if f prime of x changes from positive to negative, at c, then f of c is a relative oops, and I forgot to put of f there at the top one for that. So now the derivative is changing from positive, and if the derivative is positive on an interval, that means the function is what? Increasing. And if the derivative is negative on an interval, that means the function is what? Decreasing. So our function is changing from increasing to decreasing, from left to right, increasing to decreasing. So that means we have a relative what? Relative max. Relative max. Relative maximum of f. Again, I'm going to put because f is changing from increasing to decreasing. Okay, that's the first derivative test. So what makes it a test, the idea is like this is kind of an analysis that we can perform using the first derivative to identify relative extrema. Before, when we wanted to find relative extrema, what were we doing? Just looking at the graphs, looking at the pictures, right? We look for hills and valleys. Now we have a test, an analytical method using calculus. The derivative, the first derivative, okay, helps us find the relative extrema. Okay, so let's do this. Let's try one. All right, so we want to find the relative extrema. Excuse me, of g of x equal to 1/4 x cubed minus 3x. We'll start with a nice polynomial function. So to find the relative extrema, we could go to our graphing calculator and look for the hills and the valleys, right? Or what can we do? Find the critical points. So we're going to do that by taking the derivative. Exactly right. So good. Ryan and Emma, exactly right. So we'll take the derivative here. So we get 3/4 x squared minus 3. Okay? Now that we've taken the derivative, we want to find those critical numbers. What do we do? Set equal to 0, or when the derivative is undefined. Do we have to worry about it being undefined here?
No.
No, but I'm going to keep bothering you with asking about that because, again, 9% of the problems we do, we never worry about it being undefined, but sometimes we still want to keep that in our mind. Critical points still can occur when the derivative is undefined. So we set equal to 0, because that's the only way we can find the critical points in this situation. We'll add 3. Multiply both sides by 4/3, I guess. We get 4 equals x squared. And so then x is equal to what?
Plus or minus 2.
Yes, plus or minus 2. There's no interval here, so we want to include plus or minus 2. All right. These are our critical points. Now we go to the same exact analysis that you guys did yesterday with increasing and decreasing. That's it. We set up a little number line. Okay. And then we'll just test some points. So let's see. In this interval here, let's try like g prime of negative 3. In this interval here, we'll try g prime of 0. And this interval here, we'll try g prime of 3. Notice again here, this trips students up. We're plugging these numbers in our intervals, we're plugging these back into the derivative, right? This is like we're looking to try and find the sign, S-I-G-N, right? The sign, whether it's positive or negative, whether the derivative is positive or negative in these intervals. Because if the derivative is positive or negative, that tells us the original function is increasing or decreasing. So don't get that mixed up. It's very easy. Like, wait a minute, do I plug this negative 3 into g or to g prime? We're finding the sign of g prime. The sign of g prime, positive or negative, tells us whether the original function g is increasing or decreasing. So this is the first derivative test. We're using the first derivative. So you plug in negative 3. Negative 3 squared is 9. 9 times 3/4 is 27/4. Minus 3, so 15/4. So yeah, so we're positive there. Okay, g prime is 0. That's easy. Negative 3, so that interval is negative. And then at 3, it'd be again positive, same value. Okay. Question? You pick any number in the interval. That's it. Any number in the interval you can use. So I could have used g prime of negative 4, g prime of negative 2.1 if I wanted to for that interval. Nope, I could have used g prime of 10, g prime of 11, whatever I wanted to. And then the 0, I picked 0 because it's just easy to do math. Great question. We'll see. Oh, no, yesterday I said it won't always be that way?
Yeah.
Ah, very good. So yesterday I said it won't always alternate. So be on your toes. So, Connor, 90% of the time, it will be. But then there's going to be exceptions. So that's why I always wanted to check every single interval. Okay, so. Relative maximum of G occurs at what x value?
-2.
At x equals -2. Why do we know that?
Because at that moment it switches from increasing to decreasing.
Because, yes, the derivative changes from positive to negative, therefore the original function is changing from increasing, right? A positive first derivative means the function is increasing to decreasing because this derivative is negative. So from positive to negative, okay? Positive to negative. Positive slopes to negative slopes. And then we have a relative minimum of G, where?
X equals 2.
So for these problems, we don't have to have like a coordinate. Or will it sometimes ask us?
Yeah, no, it does not. So when it says find it, like the location is the x value. If you want to give the matching y value, you can, but it's not necessary.
Okay.
Again, if you're ever unsure, if you give the coordinate, then you're good. You're golden. Okay. So that's it. Okay. So I want to say one other quick word here. With the directions that are being asked, this is a sufficient answer. However, if we add on to the end here, justify your answer,
You write it like a sentence, right?
you need to write a sentence. The work and this little number line thing is not enough. For justification, you want to put something like because, and all you got to write is because f prime is changing from positive to negative. And yes, you must write the full word positive and the full word negative at this point. Okay, sorry, I ran off the page there. Yes. Question, Anna? Or are you just stretching? If it says justify and you don't give me this sentence, you will not get full credit. And why do I do that? Because I hate you. No, because the AP people, that's how they grade it. And I would hate for you to know everything that you're doing and lose a silly point because you didn't put the justification. So I want to practice like we're going to play. And also, abbreviations are a no-no too. So like POS for positive, NEG for negative, no good. I guess so. I don't know. They might accept that. Also, like the plus, don't ever use like if you're trying to talk about the word positive, don't ever use the plus sign for positive in a justification. This is fine because they don't. I mean, this is just for our own sake. For your justification, though, you have to use the words. Because they're like, because f prime is changing from plus sign to minus sign. Why is that? Okay. And then the relative minimum is of g at x equals 2. Because f prime is what?
It's changing from negative.
Yes, negative to positive at this point.
That is really bothering my OCD.
I know.
Like you wrote like out of the box.
Sometimes you have to think outside the box. Sometimes you have to write outside the box too, because you box it in too early. What if I do this? Will this help?
No, that's horrible.
And what if I do this?
Terrible. That is horrible.
All right, we're good on that? Let's try another one.
Oh, Callie, go Callie. Let's do it.
Okay, find the relative extrema of f of x equal to x e to the x.
Yes.
All right, so Joey, what do we do? Let's derive it. Okay, great. So when we go to take the derivative here, Joey, what are we going to do? Yeah, product rule. Okay. So lead me through. What's it going to be? Sum rule. Okay. Times 1, yeah, okay. Okay. Yep, looks good to me. Okay. So there's the derivative. All right, thank you, Joey. Anna, now what? Sorry? Factor out an e to the x. Okay. And we're going to set the derivative equal to 0. Thank you, Emma. Well, that's right, Anna. But I mean, you weren't wrong with what you said either. That was correct. So I mean, no, that's right. I mean, that is the next step. She answered them, so that's okay. Okay. I was very vague in what I was asking about. All right, great. So Anna, now what? Okay. So yeah, set each factor there, e equal to 0. When does e to the x equal 0, Anna? Never. And then the other one's easy, right? It's a very simple equation. Great. Thank you, Anna. Let's go to Connor. Now what? We've got a critical point. Oh, we forgot to check. Could our derivative be undefined?
No.
Yeah, there's no denominators or anything like that. Yep, so just -1, that's all you got to worry about. Okay, so we'll make a number line, -1 in the middle. All right, what numbers do you want to check here?
Check -2.
Okay, so we're going to plug -2 into the derivative, that's right. And then what's the other number you want to check?
Number 1.
Oh. He's not an idiot, guys. If he wants to do extra work, that's his choice, okay? Maybe Connor's just trying to give himself some extra practice.
Connor.
Some people just want to see the world burn, okay, guys? He could have said pi. He could have said pi. I mean, it could have, okay.
Yeah, he could have said E.
Okay, -2. So, this is important, all right? So, Emma, this is what I wanted to point out. So, this is something you should be able to figure out without a calculator here. So, let's kind of like work through this. I'm going to go to the factored version, kind of like what we saw yesterday, right? E to the -2, positive or negative?
It's positive.
It's the same thing as 1 over e squared, which is positive. So this is going to be positive, and then 1 plus -2 is negative. So what's a positive times a negative? Negative. Now, did I need to know the exact value of e to the -2? No, but we were still able to analyze that. So that's kind of an example of something we should be able to do. E to the -2 is the same thing as 1 over e squared, right? E is like 2.6, 2.6 to a square, right? It's still going to be positive, and 1 over a positive number is still a positive number. Whoa. Did you follow me? Okay? So, then plugging in the -2 here, plugging in the -2 for this one, -2 plus 1 is -1. So it's going to be a positive number times a negative number, and so we're going to end up with negative then from the interval. And then for 1, e to the 1 is positive. 1 plus 1 is positive, so it's positive times a positive. It is positive. No, it was not. Okay? All right? Great. So, Brittany. What's ugh? So, F has a relative what? Minimum. That is correct. At what? X equals -1. It didn't say to justify here, so we don't have to justify. If we wanted to justify, it would be because what? Because, so, and be careful. Also one thing, no pronouns. So don't ever put because what is it referring to? Because F prime, no, but initially, but it's okay, it's not a problem. Because F prime is changing from negative to positive, that's all you got to say at this point. F has a relative minimum and X equals -1 because F prime is changing from negative to positive at this point. Donovan? You don't need to say that. I think by leaving it out, then you're saying there isn't one. So you could say there's no relative max if you want to be very thorough, but I think you're okay with not. Okay, listen up, guys, real quick. This is important. Emma's question was, why aren't we saying that F prime has a relative minimum? That's what your question is, right? Why are we saying it's F that has the relative minimum? The original question was to find the relative extrema of F, original function, okay? So, how do we find the relative extrema? In the past, the only way we had was the graph. We would look at the graph, we look for the hills or the valleys, right? How do we use the derivative then? Why do we use the derivative? Because the derivative tells us about the slopes, right, where our function, the original function, is increasing or decreasing. Follow me, right? So, like we talked about yesterday, where my function's changing from increasing to decreasing, that gives me a relative max. That shows up in the derivative as changing from positive to negative. Or where I have a relative minimum, that's where my function is changing from decreasing to increasing, which in the derivative is changing from negative to positive. So that's why, yes, the thing we're using to determine this is the derivative, but it's talking about, or it's analyzing the original function. We're transferring it back to the original function. So that cleared it up for you? Because it's very important. Other people get this mixed up too. So thank you for asking that. All right? All right, I got one for you to try.
Does it do something like find the relative extrema of money?
Yes, it does. How did you know?
That's good.
All right.
Yeah, right?
There you go. Now, let me just give you a little help here with this, a little tip. What are we going to be doing with this function? So, product and a chain rule, right? My recommendation, when you do the product rule here, immediately after you do the product rule, look for GCFs to factor out. That's going to help you, okay? So look for GCFs to factor out and factor those out, okay? I'm going to go make copies of this little graph that I want you guys to have in your notes, and then I'll be right back, okay? So, get to work on that.
What? This is really like awesome. Okay.
Got any question?
Yeah, exactly. We're going to do it eventually.
Right there, Jack, sorry. Check your analysis here with the signs. I think... Hang on. Alright, here. Gosh, oh!
Did you write that wrong?
Yeah, it's not the one. That's okay. We'll just do the one that I wrote down. I wrote down incorrectly. That's okay.
Alright.
So that could be
correct because -4 would yield negative.
Well, actually, we can really easily check this using our calculator.
Yes, we can.
So yeah, you should have a relative
Cool. Always a straight curve like that.
No.
Zeros are 2 and 3, right?
2 zeros, negative 1.
Oh, and negative 1 out?
Yes, correct. No. Okay, okay. I think you did it for me completely. Okay? Do you understand? That's the way. That's not like, oh, I did it wrong.
I know, I need to do another one. Positive, negative. Do we have an assignment?
A show?
Do we have an assignment, like homework?
Yeah, I'm gonna give you a, I want you to go around a little bit too, so.
What are you doing? I used to equal 0.
Never equals 0, right? So, but it's still part of the function, we'll talk about that too.
So you just leave it out of that section of the.
You don't set equals 0, no, but we do, because now when you're evaluating the derivative.
I didn't even factor it through out, I just left it in there. But I got to say,
You and John.
I haven't had her like this week.
But he's related to me, that doesn't count.
And then she does too.
Ryan, you look
That's nice.
like you're in a very bad position right now.
You're looking for it.
Ryan's like trying to push the calculator into his head. He becomes
Oh, only 4.
I know when you should.
Okay,
positive, negative, positive, positive.
we have a relative maximum where?
Oh, wait, no, that's right. Wait, what?
Relative maximum of f. At x equals negative 1/2. We have relative minimum. Ugh. Handwriting went even worse. Of f at x equals what? Negative 3 and x equals 2. Okay, now, questions on any of that?
Just like crashed really hard.
Okay, so I made a mistake in this problem. I meant to make one of these cubed, but that's okay.
No, we have plenty of minutes on the clock.
So, yeah, we got this, guys. No, I'm not going to make you do that, though. But I do want to show it to you, just real quick here, please, because I wanted to come back to what Connor was asking about earlier. So if I change this x minus 2 squared to an x minus 2 cubed, and then x plus 3 squared, Now when I go to graph it, actually I'm just going to show you the work. I have the work here. I have a previously prepared example from another class, so then we'll just look at this one. Okay, the derivative works out roughly to be still the same, like, basic idea.
Like find the function.
Okay, so derivative still works out to be the same idea. You still factor it. You get these critical numbers. Okay, that's no different. I don't really care about that. But here's where I really want to make sure I point something out. Here, okay, we end up with -3, -1, and 2. And when we do our analysis, you'll notice that at the 2, even though it's a critical number, it's from positive to positive. So is there a relative extrema here? No. Okay? So that's why you always got to check every single interval. Don't just assume it alternates. Once you find the first one, don't assume, oh, if it's positive, it's plus, minus, because sometimes it doesn't.
Oh, is that one of the things that I feel like?
Yep, and if you look here, at 2, you'll see it kind of like flattens out and then goes up still. It does not flatten out and go down, it flattens out and goes up still. Like a cubic, which is what? Cubic. Okay? So there's that. Alright, let's take a look then at this little graph I gave you guys. I'll bring tape around too. Okay. Let's look at what we're given here, because this is super important. Oh, actually, sorry, one last thing I wanted to mention. I know, gosh, Mr. Whitmire, this is like beating a dead horse. But when you factor out a coefficient, Tyler correctly pointed out, 2 never equals 0, so we don't have to worry about there being like a critical number from that 2. But when you go to evaluate your numbers back in the derivative, don't forget that you're multiplying by a 2 out front here. Now granted, 2's positive, so that doesn't affect it. But should in a future problem you factor out something like a -2, that is going to affect your signs here. Okay? So this is like a -2, and you only are like checking these numbers here, and you forget to then multiply by the -2 out front, you're going to get the wrong signs. In fact, they'll be the complete opposite of what they should be. Okay? So when you're factoring out numbers, like the 2 here, it doesn't, obviously it'll never equal 0, so you can ignore that part. But when you go back and evaluate these numbers to test, the 2 is part of the derivative. So you do -4 minus 2, -4 plus 3, 2 times -4 plus 1, and then times the 2 to get the right sign.
You just like do it normally and then just
Yeah.
flip it at negative.
Yep, exactly right. You can just flip it if it's just a negative. Yep. All right, back to this. Now, notice what we're given here. This is a graph of what?
F prime.
F prime. I'm asking you, letter A, where is F, not F prime, where is F increasing or decreasing? How are you supposed to do that? I've got to graph an F prime. How am I supposed to say anything about F?
Because
Okay. It's the slope.
where
That's
there
right.
are any negative values on F prime, that is going to be where F is decreasing.
Right. How do we, that's exactly right. How do we use the derivative to tell us where the function's increasing? What did we look at yesterday? Okay, what values though? Positive values, right? Positive y values, and the derivative means the original function is increasing.
Good boy, yeah.
So, right, do I have y out? It's back on my desk. Okay. So, where is my derivative positive? On what intervals? -4 to 1, and
whatever that.
yeah, we'll say about 3 to 4. We'll probably say it's about 4 there. Okay. So yeah, F is increasing. Okay, from -4 to 1 union 3 to 4. Okay, because F prime is positive on that interval. Okay, F is decreasing. Yeah, we'll say the other one's -5. Yeah. So now, how do you know when F is decreasing? F is decreasing when F prime is what? Negative. Where in my picture here is the graph of F prime negative? From what to what? -5 to -4. Union, yeah, 1 to 3. Right, so relative maximum of F, at what x values do we have a relative maximum? How do we determine relative maximums? It's when the derivative changes from from positive to negative. Where in my graph here does the derivative change from positive to negative? At 1, and that's it. So it actually goes 1. Okay? And then where do we have relative minimums of f? Okay? That's where the derivative changes from what to what? Negative to positive. And so where we change from negative to positive? Negative to positive, negative 4. Negative to positive at 3. Okay? This is what I mean by being comfortable about, you know, kind of like transferring data from the derivative to the original function and then vice versa. Here we're given the derivative. Right? Does the derivative have relative extrema?
Yes.
It does, okay? We're not worried about that right now. We're trying to find the relative extrema of f. So try not to get those confused. It's very easy to get them mixed up. Okay? All right.
You guys are class 2 reason. One more time.
15. Yeah. And then we go to Earth Block.
So what time is the class?
35.
It's the schedule in the back. 10:40 is what it looks like.
So it's 25 minutes longer?
I guess so.
Whiz. Oh yeah, so this is 10 to 25 minutes, and then the fourth block is 10 to 15.
Okay, here we go. It's going to be page 226 to 227.
No point in this.
The competition.
Like that.
And I'm going to say 103 as well, because we didn't do that previously.
That's not it, is it?
Oh, that might have been the right section, though. Hang on, let me check.
218?
229, 103.
That'll be the same. Right?
It will be the same section. Okay? Let's get crack-a-lacking, folks.
Go Drew.
Like what?
Tape from the graph.
Tape, yep. I'll get you tape.
Yeah, I better know that they get this